Hello, geometry class. Excuse me. This is CP1, lesson 3. We're going to talk about the following items today. We're going to calculate the sum of the interior angles of a polygon with any number of sides, and then calculate an individual angle measure of a regular polygon. Recall that regular polygon means that all sides and angles are the same. Well, all the sides are the same in their measurements, and all the angles are the same in their measurements. After we're given that we know the sum of the interior angles. So let's go ahead and get started. All right, so let's take a quick look at some prior knowledge as well as incorporate some new information here. What you'll notice here is that I've got this weird notation, which is not very formal at all actually, but we know that within a triangle, the sum of the three angles of a triangle is 180. So if I were to look at a quadrilateral, some of you may know that the sum of the interior angles of a quadrilateral is equal to 360 degrees, but you may not know why. Likewise, the sum of the interior angles of a pentagon is 540 degrees. So let me help you to understand why it is that this is true. So I'm going to take a vertex of this quadrilateral as well as one vertex of the pentagon, and I'm going to draw all possible diagonals from that vertex. So a diagonal is consecutive or non-consecutive vertices attached by a segment. So you can see in the quadrilateral, I'm only able to draw one diagonal. And when I draw that one diagonal, I get two triangles. So I get two triangles. Now, how is that related to the sum of the interior angles? Well, we know that the sum of the angles of a triangle, interior angles that is 180. So if I've formed two triangles, I really have a total sum of the interior angles to be two of those. Likewise in the pentagon, if I were to split this up into three triangles, then I know that I have three shapes whose interior angles add to 180. So when I multiply 3 by 180, I get 540. Let's continue on to the next slide to develop the general formula for this situation. All right, so with the quadrilateral, we took 2 times 180, we got 360. With the pentagon, we took 3 times 180 and got, whoa, that's definitely wrong. How about not 360? How about 540? I'll change that one in the old notes. What do those blue numbers mean? Those mean the number of triangles. Number of triangles present. All right, so if let's talk about number of sides, n, and number of triangles. Okay. So if I had 3 sides, there's 1 triangle. 4 sides, we set up here 2 triangles. If we took that, excuse me, diagonal method, all right, from one vertex. If I had 5 sides, which is a pentagon, I get 3 triangles interior or inside of that shape. What about 6? Well, I'd anticipate that 6 would give me 4 triangles. Now let's go out to a general term. Let's call it the nth term. Well, what you'll notice here in our pattern, 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4. So if I have n sides, then I have n minus 2 triangles. Okay, so if I wanted to know the sum of the interior angles, that's what that notation there is going to mean, sum of the interior angles. I would take the number of triangles minus 2 times 180. Oh, excuse me. I take the number of sides minus 2, which gives me the number of triangles. Okay, so n is the number of sides, and minus 2 is the number of triangles. within that shape. All right, let's utilize that. So here I have my formula, and I've got a short word problem. It says find the sum of the interior angles of a dodecagon. So all that I need to know is how many sides on a dodecagon, and I know that's 12. So the sum of the interior angles of a dodecagon would be 12 minus 2. Remember, number of sides minus 2 gives you the number of triangles, times 180. So the sum of the interior angles would be 10 times 180, which is 1800 degrees. All right, let's continue to the next example. All right, interesting example here. I want to find the measure of angle ABC. Well, here's angle ABC, and notice how it's marked the same as angle, well, I guess we'd have to name that angle, but I'll just call it angle C. Okay, I'm going to call each of those X, just for the time being, to kind of be a placeholder. I'm going to utilize some other skills from previous chapters. These two angles here, 68, and this blank angle here, they're going to add to 180, so this angle should be 112. And likewise over here, this angle would be 110. Now you'll notice that I've got 1, 2, 3, 4, 5, 6 angles. That means I'd also have 1, 2, 3, 4, 5, 6 sides. So in this case, I know that n equals 6. This is a hexagon. Okay, so if this is a hexagon, the sum of the interior angles of a hexagon would be 6 minus 2 times 180, which would be 4 times 180. 4 times 180 is 720. Now again, my goal is to find the missing angle value. So I can write an equation using the 6 angles that I know. I know I have 110, I have 116, I have 112, I have another 110, and then I've got 2 X's, which are the same measure, and those should all add up to the sum of the interior angles here. All right, so I'm going to add up the like terms over here. Those add up to 448 plus 2 times that unknown value X should equal 720. I subtract, so 2X should equal 272. And now I divide by 2, and X equals 136. Now the question wasn't asking for X. The question was asking for the measure of angle ABC. Now those two things are the same. However, you want to formally address the question being asked to you. All right, let's look at another example. All right, now if a polygon is equiangular, then you can find the measure of an interior angle by manipulating the formula that we know. So let's take, for example, we already know that a pentagon, the sum of the interior angles, is 540 degrees. Right? So each of these 5 angles, A, B, C, D, and E, the measure of those angles add up to 540. But what if they're all the same? Then to get a single interior angle, I could take that 540 and divide it by 5, which would be 108. Now, generally speaking, to find a single interior angle, I could take the sum of the interior angles and divide by the number of angles, or number of sides. So n would be the number of sides, or you could consider that the number of angles. Specifically, we know that the sum of the interior angles is n minus 2 times 180, and then we would just simply divide by n. That's going to be how we will find a single interior angle of an equiangular polygon. Now, equiangular could also be referred to as regular. So regular just adds that the sides are all the same measure as well. Okay, so the only time you'll use this formula is if you want to find a single angle of an equiangular or regular polygon. Let's look at an example or two. All right, so it says here, calculate the measure of an individual angle in a regular decagon. Okay, so in a decagon, n equals 10. We're going to utilize our formula. So a single angle, note that this is a single interior angle, would be 10 minus 2 times 180 over the number of angles or sides, which is 10. 8 times 180 is 1440. And 1440 divided by 10 is 144 degrees. So a single angle, interior angle of a regular decagon measures 144 degrees. All right, let's look at a couple more examples. The first one here says the sum of the interior angles. So the moment I see the sum of the interior angles of a polygon is 1080, I know I will be using this formula here. It asks how many sides does it have, so we want to know what n equals. Okay, so if I know the sum of the interior angles is 1080, I'm going to set that equal to n minus 2 times 180. And then I'm going to solve for n. So I want to isolate n. This is just solving for a linear equation. A couple different ways you can do this. The first thing I would do is probably choose to divide by 180 on both sides. And when I divide 1080 by 180, I get 6 equals n minus 2. Now to solve for n, I just add 2 to both sides. And it looks like n equals 8. So it looks like our shape was an octagon. All right, in the second example, it says if an angle, once you see an angle in a regular polygon, and you see regular or equiangular, what you're going to want to do is use this second formula. All right, so the single angle is 120. I'm going to set that equal to n minus 2 times 180 divided by n. Okay, so what I would suggest in solving this is multiply both sides by n. And then distributing the 180 to both the n and the negative 2. So you get 120n equals 180n minus 360. Now, the temptation is to combine terms that aren't like terms. These are the only like terms up here. So I'm going to combine them by subtracting 180 from both sides. That gives me negative 60n is equal to negative 360. Now clearly we want there to be a positive number of sides, so if you get a negative value for your answer, you should question your technique along the way. When I divide both sides by negative 60, I get a positive 6. So that looks like the shape being spoke about above is a regular hexagon. All right, guys, I'd like to do one homework problem, and then we'll call it a day. All right, this is number 5 from the homework. I want to find angle E and then angle F. First observation that I'm going to make is that these two angles will be the same. And the reason I know that is because they're both supplementary to this interior angle. And look how those interior angles are all marked the same. So I'm going to solve for E. I'm going to take and find E by taking 5 minus 2 times 180 and dividing by 5. All right? If that's a regular pentagon, I can find a single interior angle. Single interior angle. And I guess I don't know if it's regular, but I do know that it is for sure equiangular. So I can find a single interior angle by doing that. Well, if you do that calculation, you get 108. So E is 108 degrees. Okay, so if E is 108, so are both of these red angles right here and right here. So both of the blue angles have to be supplementary to that, makes them 72. So if I have two 72s and I add them to F, I should get 180. Well, two 72s is 144 plus F equals 180. So it looks like F has to equal, what would that be, 36? Yeah, F has to equal 36 degrees. All right, guys, there you have it. That's lesson 3 from unit 4. Working with interior angles of polygons. See you next time.